So first things first, let's be a little smarter about how we create our actors and how we space out our pegs. Very little of this is actually going to involve any Box2D coding. It's just going to be some ActionScript stuff, but we got to do it. So let's go back to the code. So the first thing that kind of bugs me is the fact that we're keeping track of our actors in these two different variables. So I'm going to create a variable called allActors. And this is going to be an array. And we will delete these other two. And I'll make sure that allActors has been initialized to be an empty array. And then here's what we're going to do. In our makeBall function, this is now a local variable. And then we will simply add it to our allActors array. We would probably add these pegs in our addSubPegs function to our allActors array as well, except that I'm going to delete this function entirely so that we can properly set up our level. So we're going to delete this. I know all that work we spent creating that function, and now I'm getting rid of it. And let's call our function something a little more descriptive, like create level. Now granted, if I were doing this in a real game, I'd probably be reading all of this stuff in from an XML file. However, I don't really want to be doing that here, so I'm just going to kind of figure it out in code. So if we take another look at our Peggle application, the one we ideally want to match, we can see that our pegs essentially take up a rectangle with the row of pegs being offset by about half the distance between the pegs from one row to the next. So let's try and copy that now. I'm going to set up a few variables here. The first one is going to be, we'll just keep track of the horizontal spacing. And I believe that's going to be 36. And the vertical spacing, which also happens to be 36. And then I'm going to record a rectangle that is going to define the bounds that we want our pegs to appear in. So I'm going to call this pegBounds is going to be a rectangle. And it will be a new rectangle. And I happen to calculate all this out beforehand, so we know that the x value is going to be 114, the y value is going to be 226, and then our width is going to be about 418, and our height is going to be 255. Note that this might be kind of big compared to the Flash movie that we have right now, and so I might need to go and increase the size of that after I've added these pegs. But we'll do that in a bit. And then I'm going to record a little Boolean variable that just kind of switches between true and false to keep track of which row we're in. So let's start. We're going to create a variable called pegY, which will be the y value of the peg. It's going to start at the top of our pegBounds rectangle. We're going to keep going as long as it's less than the bottom of our pegBounds, and we're going to increment it by our vertical spacing. Now that we've done that, we're essentially going to do the same thing for the x values within each row, but we need to figure out where our start value for x is going to be. So our start x is going to be an int that is going to equal our pegBounds dot left, and then we're going to add that little half width of spacing depending on whether we're in an alternate row or not. So I'm going to just do a little tertiary function here that says, are we in a flip row? If so, then don't add anything. Otherwise, let's add our horizontal spacing over 2. And I think this should work. And then our flip row will equal not a flip row. Now that we've figured out where our leftmost position is, let's start calculating our peg x values. This is going to equal our start x. We're going to keep going as long as our x value is not greater than the rightmost part of our rectangle, and we are going to add some horizontal spacing to it. And now our new peg, which is going to be a peg actor, is going to equal a new peg actor. Again, for now, the parent will be our Puggle application. Our point will be a new point located at peg x, peg y, and we're going to make all of them normal for the moment. And then we're going to add this to our all actors array. Close up this spacing. Looks pretty good. There's a couple things that we still need to do, one of which is at some point we're going to need to turn some of these pegs into goal pegs. We haven't done that yet. Right now they're all going to be normal. I'm saving this for a little later because this will also involve some game logic, because we're going to want to keep track of which pegs these are, so that eventually we can do the cool camera zoom when we're down to our very last goal peg. However, for now, I think this should all work. There's one more thing that we have to change. Let's go to our new frame listener, and instead of having our update now in ball actor, in fact, let's just delete this and write it from scratch. And that's going to be for each var actor in all actors. And we're just going to tell the actor, call its update now function. Because peg actor and ball actor both inherit from actor, we know that they're guaranteed to have an update now function, and this all works fine. Or it should. I'm going to hit F6 and see if this actually does work. Oh, look at that. It seems to work pretty well. As I might have mentioned earlier, our pegs are a little too big for our stage. So let's actually adjust the size of our stage. Turns out the properties we want our stage to be about 646 wide and 603 pixels high. This will look pretty good. Say OK. Save it. Let's run it one more time. There we go. That looks a little more like a Peggle application, although it looks like our ball keeps falling off the left-hand side there. We'll want to add some walls, so maybe let's do that before we get to the cool peg lighting up part of it. Yeah, we're going to get that next.